I am making a backing plate for this old Cushman chock. And hopefully it's going to fit my vintage Karger lathe one day. So far I managed to hack up a piece of scraptonium with my vintage hydraulic hacksaw. I did some drilling, a little bit of turning, and I suffered through a whole lot of chatter when doing some internal boring. You can see all about that in a previous episode of the shit show. For the next part in this project, I'm going to give myself and the old lathe a bit of a workout when I try to make a fitting spindle nose thread using the old lathe sliding spindle threading mechanism. But first a quick tool change without using a quick change tool post, because I need to use my CCMT boring bar to cut a spindle nose register in this future backing plate. More speed. And a little faster. And here we go. Hopefully the chatter won't be too bad this time. I'm taking very light cuts, but still it rumbles a bit. Adding a bit of oil. And let's try again. I tried different speeds, but the rumble never went completely away. One day I will hopefully figure out what's wrong with this lathe, but for now I will just suffer along. I probably should have cut the register after making the spindle thread. That might have been easier or better, I don't know. Measuring the depth and the width, and it looks like a bit more has to come out. But this is where I made a mistake, as you will find out near the end of the shit show. Next I'm going to cut the lead in for the spindle thread using this weirdly ground brazed carbide bit. Because of the large contact area, I'm going to turn the lathe by hand. And even when turning by hand, you can hear the lathe rumble a bit. And I'm starting to think that the problem might be in the bench, or the way in which the motor has been mounted to the bench. Of course I could not resist starting the motor for a bit. But for this job, on this lathe, manually turning the spindle just works better. Besides, it's a good warm-up for the single point sliding spindle threading that's to come. With the lead in finished, it's time to set up the threading bar and start breaking some pointy bits. By the way, you can now place your bets on how many tips I will break during this procedure. The answer will be given somewhere near the end of the shit show. And now it's time to loosen up the spindle and engage the threading mechanism. Basically, the thread is copied from the template on the rear of the spindle onto the workpiece. I have a few more templates for very fine metric threads, but this 8 TPI imperial thread is the only one that is of any use to me. It would be cool if I could make some more templates with a matching spider for more useful threads. I guess I should put that on my bucket list. Alright, Time to set the angle on the top slide to a little under 30 degrees. I hope that block of steel is a bit square. Well, it's probably good enough. In the past I have plunged in the tool straight, but setting the top slide to an angle just works a little bit better. Now I'm checking how the tool lines up with the workpiece when it's sliding forward. And here I'm making a mistake by moving the tool bit a bit too far forward. You'll see later what I did wrong. It's time to make the first scratch. I will speed this up a bit because it is rather boring footage. Maybe one step up from watching paint dry. And back it goes. Of course after backing out the tool bit with the cross slide. I took off the belt, otherwise there would be too much tension when the spindle moved forward. So how about some workout music? Now music with machining videos is not really my thing, and I would prefer some Pink Floyd or some rock music, but that's not royalty free. So let me know what you like. I might make it a thing if it gets me 100k subscribers. I'm sorry, that electronic music is just terrible. Forget about that idea. And I don't want to search the internet for more of this royalty-free crap. Turning back the spindle. And I'm going to shut up now for a while and fast forward through the next couple of passes. Don't worry, no more music. And there you can see the pointy bit, and it looks like the tip is already damaged. It's probably time to turn the insert to the next pointy bit. But you'll be surprised how long you can actually continue with a broken off point. Although it gets harder to turn and the thread will look terrible, so at some point you will need to switch the insert. I cannot back out the tool any further, and that's a mistake I made when setting things up. So now I have to take out the tool, replace the insert, and hopefully I can line things up again. But it's still early in the thread cutting process, so I'm confident that I can still save the workpiece. Here you can see the broken off pointy bit, and more will follow. I decided to switch to a cheap ass 55 degree insert. It'll be fine as long as I finish the thread with a 60 degree insert. And here you can see the thread so far, now that the tool is out of the way. And now comes the hard part, lining things up again. And with the threading bar in the way, you can hardly see anything. But I'll try, and at the end of the shit show you'll see if I succeeded or not. Well, that cheap 55 degree insert broke almost immediately. I failed to film that, so now I'm taking a pass with a broken off tip. I'm doing a few more passes. And now it's time for a little cleanup and a new pointy bit. Wait for it. Ah, shit. I can't do anything with the camera in my way. The things you're willing to do to make a decent YouTube video. And here we go again. Excuse the bad focus. It feels a little bit off, and I think I messed up the alignment. You can actually see it on camera below the tool bit. But in real life I could not see anything, so I'm just pushing through. Fuck it, it will be fine, I promise. God. I guess the insert won't be fine, because another pointy bit bites the scraptonium. A new tip and the workout continues. Walking to the other side of the lathe, trying not to hit the camera or the light stand. Winding back the spindle after backing out the tool bit. Dialing in another cut, or maybe it was a spring pass. And here we go again. A little cleaning, because it's time for a new pointy bit. And this time I was smart and used a magnet, because I lost 2 screws in the swerve bucket. And the dance around the tripod under the light stand can continue. It's important to keep the tension on the spindle, because if it springs back too much, there's a good chance the carbide point will snap off. But you will definitely need a few spares for a job like this. Alright, I will speed this up a bit to keep the video nice and short. Last pass, and then I will move the cross slide out of the way and test fit the thread with a 1-inch tab. The last walk around the tripod. Now you might think, why isn't he using that tab from the start and forget about that stupid sliding spindle workout? Well, trust me, I tried, but I cannot do it. Not enough leverage, no spindle lock, makes it impossible for me. You also need super strength to turn this thing, even after sharpening it a bit. It feels good. I think we're done. Now the top of the thread looks lightly cross-threaded, but it shouldn't matter as I expect it is plenty strong enough. Disengaging the sliding spindle threading mechanism. Phew, I'm glad that's over. Hard work manually turning a thread. But I guess I need a little extra workout with the tab. Unfortunately, I'm not talking about the bear tab. In the past I have skipped this tab, but the size of the backing plate gives me the leverage to try and clean up the thread with the tab. I'm not strong enough to push the tab all the way through, but that's not a problem as the thread is more than long enough for the spindle nose. So I'm probably pushing it too hard for a YouTube video. And here is the finished thread up close. Not bad, I'm happy with it. Although you can see that the tops of the threads have been a little cross-threaded. You can see it a little better in this picture. Even an old Chuck needs a bit of love now and then, especially when your name is Chuck. Alright, Chucky needs to go now. And now comes the moment of truth. Will it fit? The thread feels fine. There's not a lot of side-to-side slop. But unfortunately, I did not cut the spindle register deep enough. That's a stupid mistake, so I guess Chucky isn't done for the day. But first I need to set the top slide parallel to the lathe bed again. One little mistake that results in a lot of extra work and a rather long YouTube video. Good enough for this guy. Let's fix that spindle register now. Here's Chucky again. The backing plate goes back into the chuck. Fortunately, I don't need to change the size of the spindle register, only just the depth, so precision is not really that important. But I did reposition the workpiece a few times to get it somewhat dialed in. Another quick tool change. Without a quick change tool post. I used the flashlight to line up the boring bar, and then I did some more manual turning to scrape a bit off the bottom and make the register a hair deeper. No cleanup needed this time. So bye bye Chucky. The new backing plate does get a little cleaning. And now it's time to test fit again. That looks a lot better. Problem solved. Let's look at the front wobble with the dial indicator. And I also use my famous analog surface tester to check the surface finish. Perfect. Well, almost. But I'm calling it a win so far. Now the next thing I need to do is cut a register and drill a bolt hole pattern. But that will have to wait a while, because my Chinese drill press is not really capable of drilling holes bigger than 10 mm, and the pulley on my bigger drill press is spinning on the spindle, and my Chinesium mini mill is not yet operational. I also haven't decided yet how I am going to cut the chuck register. You see, I don't have a reference surface to set the internal taper against, and the surface in the chuck also has some damage, and I'm considering grinding those away, then cut a very short register and file it till it fits. If you guys have any ideas or suggestions, leave them in the comments below. So you probably have to wait a while for the next update in this project. I almost forgot to give you an update about the pointy bits I used. Well, here are all 3 of the slightly used inserts, but they got the job done. Since I cannot zoom out any further, I'll bring you in closer. So let's have a look at all 9 pointy bits. Compared to the other 2, this one almost looks brand new and is ready to go for a few more passes. The 55-degree insert took the most damage, but that's not a big deal because I got more of them. Well, they were supposed to be 60-degree inserts, but you know how things go when you are buying and using Chinesium tools. But hey, I'm not complaining, but I doubt that a single brand name insert could have completed the job, and that would have been a lot more expensive. Well, that's it for this week's shit show. More to follow, hopefully next week. But bye for now. And now I go hunting for those little screws that fell into the swarf bucket. But I ended up buying new ones. I also ordered a dead cat microphone, because the wind noise in this clip is terrible. People will probably unsubscribe now.